So next, going for the range function. So what's the range function? What we can do with this? To start with, range is one of the functions in Python. Using that, we can work on creating the range of values. Till now, we are generating a single value, but now we will discuss on how to create more than one value. So basically, it is a built-in function which has some features. So as I'm saying, range is like a function. In Python 2, there used to be two ranges, range and X range. So the X range of Python 2 is called as range of Python 3. So what is that doing? I will tell shortly. So if I take range of values, if I do like a range and I'm trying to assign to something, and if I try to run it, it will throw an error. I go to the language components and 067, so clear and Python. So a range function. Did you see that range expects at least one argument? So this function will not take emptily. So till now, what are the functions you are taking? Either you pass your variable or like you call with it. But you see this from here onwards, you can see new things. And if you want to know more about this range function, what all we can do, as I told you yesterday, in terms of the help, you can use the help built-in function. Help don't need a print statement to help you, but it shows you. So what it is saying, if you pass one value, like that also it can create a range object. If you can pass three values, in that way also it can take a range object. And it is saying like, this is an optional. So means there are two ways in which you can make a call to this range function. One value or two values or three values. So what it does and all these things, these are all the how it was implemented. But sir, I am not interested in these things. So once you are done, you need to type a Q so that it will come out of the help. Now I understood the help also. If I need to understand what actually this does, I can give like a single value and ask it to print. If I give a single value, then whatever you are giving, it will treat that value as the final value and it will give the remaining things. Means whatever we give is the final value. Generally, range will take three values: the initial value, final value, and the step. So whatever you are giving is treating as a final value. Then what about the remaining two? Means those were defaults. So there is no default final value. You may think similar to what you are doing in slicing, right? String slicing and other slicings. But it is slightly different. In slicing, you create the indices and then you apply on that string. So here you are creating the list of values, or like you can think like some numbers you are generating. So when you give like a final value, as I told you, it will treat the remaining two as defaults. What is the default thing? The default initial value is 0. What is the final value we give as 9? Then what is the step? +1. If I see now, you should generate the values like this: 0 through 9 with a step of 9. If I now ask, hey, what is the type of this value and what is the values? Did you notice that it is saying I am of type range and these were my values? Where are the values? Yes, that is the difference now. In Python 2, if you are asking for the range function, the same thing, it will give a list of values. Whereas in Python 3, it will not give. So that is the difference. So it is more advantageous to not to get all the values. Why, sir? Means very simple. In this case, we are generating values from 0 through 9. What if user gives 0 through 1 crore? Means you need to generate those many values and store in the memory. So it will have a lot of impact on the memory, right? So to avoid that kind of things, they created these kind of lazy evaluation or lazy loading objects. So range is the first such lazy loading object you'll see. Subsequently, I will show you a lot of things like iterators, generators, and others. So what is this concept? So you may think difficult, but try to understand. Sir, it need to generate values from 0 to 9, but we are not seeing the values. Means only when you need the values it will give in runtime. It will remember that, yes, I need to give values from 0 to 9 with a step of 5 or like with a step of 1 like that. So means it will know the state. This is called as storing the state rather than storing the values. This is a new approach. So similarly, what if you are asking like two values if you pass? If I pass two values, it will treat like initial value and final value, and the step will be default, which is like +1. You can see in this case also, you get the same thing. Or else, if you give like three values also, it will work. Say, if I give three values, it will treat them in the same order. Initial value, final value, step. And did you see? In all three values, you're not getting the actual values, but you are getting like this. Now, sir, how to get these values? So range will work whenever you're doing a looping or converting. So if you want to do like, say number you want, right? For each number in values, I want to print each number. If you execute now, did you see? I told it will start from the starting index, it will go till the final index, but doesn't include, right? That's what I told in indices, slicing. Same thing here also. Whenever there is a boundary, it will go till the last value, but doesn't include the last value. What is the last value? 9. So 9 will not be included. So -1. So means 8. Till 8 only it will come. And did you see step is +1? That's why every value you are getting. So what is this concept means? It is called as a dynamic or like on-demand execution. Only when you need something, it will execute. In this way, we can better handle the memory, right? So that is the beauty of Python. Next, now I will ask one after you. You need to help me. Sir, what is the best way to get these values, sir? Either like this we can do, or we can do a for loop on it to convert. There is something called as a list, which is a built-in function for converting. Say I'm taking the same range 0, 9, 1. So instead of printing that range element, I am converting to the list. Now, did you see all values you got in a list? But generally don't do when you're doing in the production code. It's for a better management. As I'm learning right now, we are doing with converting to list. Now, let me take one more example. Say, for the same values, if I want to convert to different data types, I have different built-in functions. Instead of converting that, can I do like this? Means same values which are assigned, right? I can execute again. So this is where you are storing the values in square braces. It's a list. If you are storing in parentheses, it's a tuple. And if you are storing in flower braces, it's a set. So these are the different data types we have. So how to get the values from the range? Either for loop or convert to a different data type. Now going for the next step. So what if I give something like this? Means value 2 is equal to 0 to 9 with a step of 2. I'm converting to a list such that I can visualize all together. Means from 0 till 9, it doesn't include 9. Means it will go till 9 and up. So you are getting like every second value. If you see here, you will notice 0, 0 plus 2 is 2, 2 plus 2, plus 2, plus 2. It's going till 8, but doesn't go beyond because that's a limit. Similarly, what if I tell that, hey, we need to go for something like this? You see, in this case, what will happen? It will start from 0. It will go till 9 with a step of -1. I told you the same example there also. Whenever you are going for a step which is not coming towards between to these boundaries, then you won't get anything. Means 0 minus 1 will become minus 1, which is not within the bounds of 0 to 9. So you get nothing. But sir, what if I do the same thing in a slightly different way? Means what if I change it like this? Instead of 0 to 9, I'm making like 9 to 0. So now 9 minus 1 is 8. So isn't it between 9 and 0? Yes. So you will get it. So how you get it? First, you get like 9. 9 minus 1 is 8. Minus 1, 7. Minus 1, 6. Minus 1, 5. Minus 1, 4. Minus 1, minus 1, minus 1. So 1 minus 1 is 0. So that's why it will stop there. If you execute, did you see the same answer? Now, let's go for one more example. What if I say that, hey, I want the values from 9 to minus 1 with a step of minus 1. So nothing to complicate here. It's very simple. Point is like instead of till 0, you are asking till minus 1. Means, in fact, you get the same values. So even including 0 also. So 1 minus 1 is 0. 0 is not the last value. Minus 1 is the last value. So you get one more value. So that's the difference. Now, if I go some more step ahead, what if I ask 9 to minus 1 with a step of minus 3? If you see here, initially 9. 9 minus 3 is 6. 6 minus 3 is 3. 3 minus 3 is 0. 0 minus 3 is minus 3, which is beyond the limit. So it doesn't mean that everything should be consecutively. So what are the steps we give? It will take that step and work with that. Now, beyond this, what if I am asking the things like this? If I ask for value to 9 to minus 1 itself, instead of minus 3 as a step, I did minus 3.0. Does it work? No. So basically, floating point values should not be interpreted within this thing. Okay, going beyond. What if, sir, I am asking for this one? So step is integer only, but these values are like floating. Does it work? This also doesn't work. Means you should not have any of the values to be like a floating. Neither the uh, step, nor like these starting and final indices or anything. Even all three will be like that. That also doesn't work. So everything should be integers. That's a learning. Now going beyond this range function, what else we can do? Generally, we can use the range function to do multiple actions. We can go beyond and ask what else we can do. But like, if I use this range function, and what are the logical and relational operations till now we used? In creating something called as the conditions operations. Conditional operations. As I told you, any language you will be confident if you are able to write the correct conditions. To write the conditions, you need to work with the conditional operations. Let's take the first example of conditions. I want to create a logic where I want to check whether something is even or odd. It's a very simple logic to understand. So for any number, if I have, how do I check whether the number is present or not? Say number is equal to 34. I want to print that number. So using the F string assignment, see F string assignments, together I did. So I need to come out of it 0607 conditional operations CLR and Python is a so and so. Did you see it printed A? In the same fashion, so the beauty of like F string assignment is that you just give a print like equal to in the last. So then everything will be in the same order. I just clear here such that, everything will be in the same thing. But did you notice some interesting point? If something is even, things will be like this. If something is odd, things will be different. So now I want to repeat the same things again with an odd number. Say like I am giving 35 itself. With these two, you will get some clarity. When I did a 34, I divided by 2, which is true division, you got 17. When I ask like what is the result, so it is saying like percentile, means modulo, right? Modulo, when I'm asking, it is 0 because it is perfectly divisible. And if I ask, is the remainder equal to 0? Yes. Means 34 is perfectly divisible by 2. So because it's an even. Similarly, if you go for the odd number, is it perfectly divisible? No. Does it have any remainder? Yes. Is it equivalent to 0? False. So like that you understood, right? These are relational operations. Now, based upon that, I can write a logic. So if I tell like, number is not equal to 0. If I say number is not equal to 0, it is a none. I can write the same logic here also for this. For this also I can write, or for this also I can write. If number is not equal to 0 like this, number is not equal to like this. Did you see 34 is a non-zero? Oh, sorry, instead of non-zero, I can write like even. Yeah, not equal to 0. Number is not equal to 0, that we understood. So both the numbers are not equal to 0. Both the numbers are not equal to 0. So fine. Now, what if I want to check something as even or odd? I can do the same thing by writing a condition. So the point is like, if you want to check, so the number is not equal to 0. So we can check that simply like this. Means whether you check this condition or this condition, both are same. Did you observe carefully? That's the beauty of conditions. So I told you, remember the example of a Boolean, bool built-in function. Whenever you give something explicitly like this, it will take that in the backend and check. It will evaluate the number should be Boolean true. So if it is an integer, when it will become Boolean true? When it is not equal to 0. If it is float, the same thing. If it is a string, you don't want it to be empty string. So like that, it will happen. Whenever you give explicitly, or if you give implicitly, it will try to understand. So now fine. Means whenever I write like number equal to so and so, it is indirectly checking a lot of things. Number is not equal to none, number is not equal to false, number is not equal to 0, number is not equal to empty string. It will check all these things or any of these things, right? Depending upon the data type. Now, in the same fashion, if I want to check whether something is a even division, so I divide by 2 and get the remainder, and I'm checking whether remainder is equal to 0 or not. If the remainder is equal to 0 when dividing by 2, it is perfectly divisible, right? Then it is an even. If it is not equal, so then see, you can write explicitly like this, not equal to 0, or you just write like this. So both will give the same result. Similarly, I repeat again the same thing. So if I go for like any other number also, I get the same thing. Or instead of just writing like a if statements, I can do much better, right? Instead of just doing an if, I can do like if and else also, right? So in this Python, we write the else in this way. Observe carefully, after each condition, I am writing a colon at the end and a tab space. So indentation and else, like this you can see. In this condition, it is a binary, means anything can be like a true or a false, means binary even or odd, that's it. There is nothing like a number which is not even or not odd, right? So it works like this. Now, based upon these tips, I want to give you a small assignment. Generate even numbers between 45 and 137, loop values between the limits, test the evenness of each of the number, and display if it is an even. So for this, the tip is like you can use the range function to generate the values. And then you can use the if condition just now explained for like checking the condition. If both are true, then like you can print it. It's a simple thing. If you just start, it's a very easy thing for you. Next, if I go further, if I go for like a new thing, let's now make it interesting by creating a small game. That is called as like a number generation game, number guessing game. So generally, or you can call it as a lottery game or whatever maybe. Say, we are going for something like a lucky number, which is 69, which we need to guess it. So we need to get the number from guessing number, and we need to compare both the things. How to get a guessing number? If you can get in runtime. How to get in runtime? So we can use the input function. Input function, if you use, you can get it. Okay, sir, I am using it and I am trying to print it. So you know this point. If I trying to print them, see here, and Python b so and so. Did you see? It is not printing anything. It is expecting. But we don't know what it is expecting. So we don't know what to give, and we didn't enter. Did you see that lucky number is 69? Guessed number is string, because it don't know what to take, right? So input, when you don't give anything, it will take an empty. So input will take anything like a string. So that's what happened. So when you're using runtime, it's better to pass. If you see in this example, enter a number between 0 and 100, I told. So if I say like, say 77, it says like it is 77. But did you see? 77 as a string, it is coming, right? You want to avoid it. So how do you avoid? We need to convert to int. But there will be problems. So if you give like same 77, it works. But what if you give 77.6? So then it won't take. This is the limitation of integer, right? But do you want to accommodate this change and also take like a float? That's not a good practice, right? So sometimes you don't want certain all conditions to be matched. Because you are calculating numbers, you cannot take like a floating point value. If it is breaking the code, there is another way to handle it. So that is the next chapter called as exception handling. But next we will go there. But this is how you understood. Okay, now I understood. Now we need to do the conditional checks. I need to check whether both are equal or not. So this is how we wrote a condition there, right? If guessed number is equal to the lucky number, then it is correct. Now I'm executing again. I repeat again. Yeah. If I give the same 77, what it says? Hey, lucky number is 69. You guess at 77. So both are not equal. What if I give like 67? Again the same. Hey, you guessed it like this, but both are not same. What if I give 69 now? As this condition is perfectly correct, it is going it. But here, just imagine, in 100 numbers, there is only one lucky number. What is the probability of success? 1%. Just imagine that if you are creating a game where users are every time trying and it is not giving any output. Do you think like the game is working perfectly and you didn't answer? As a layman, what you will think? So you think like, the game was stuck. So what is the best option? Instead of giving like a simple try, we can give like a try exception. Means if I do like a try case and an else case also, if case and else case, then what happens? If it is correct, it will say it is correct. If not, it will say something else. So it is saying, please try again. At least user get a clarity that, it is taking my input, processing, and I am wrong. So in the first case, what happens? You are just printing it. So now you understood, right? In which case you need to go to the if, in which case we need to go to the if else. So as a user, as a developer, you need to take that choice, whether to go with something or not. So in this case, if I do, I'm giving 68. It is working. So I'm trying hard, So from 10 onwards, I try. From 10 onwards, I'm trying. Okay. It is saying false. Then I tried 20. Then it tried false. Then I tried 30. It was false. Then I tried 50. It was false. Then I'm trying 60. Then I'm trying 60. It was false. Then I tried 70. It was false. And I'm going on trying even 80, 90, so and so. At this moment, you know what is this lucky number. What if you don't know? You will also play like a third party, right? But the problem here, what happened? You played, it got 80, but still you are not sure. After some time, what happens? If you are not getting success, you will get bored and vexed and you will leave the game. So instead of this also, we can make it much better. How do you make the user to be more engaged? Instead of just telling please try again, we can check each time and tell that how relatively you are. Means instead of just one condition, we can go with another thing. The first thing is same. If you guess it correctly, everything is fine. What if you didn't guess correctly? So the guessed number is greater. So then just imagine 69 is our actual lucky number. What if you are guessing 78? Means your guessing number is greater than the original number. So don't you think you need to try to reduce your guessing number? Similarly, what if you are guessing a lesser number? What if you are guessing 34, which is less than? Then we need to increase the guessing number, right? Now, you see how interesting will be. I again start it. I start with 10. What is saying? Hey, increase your guessing number. Means you understood that the number is not between 0 to 10, but something beyond that. As max is 100, 10 to 100. Then he tries randomly 25. Now it is saying increase your guessing number. He understood from 25 to 100. Now again he gives 45. It is saying to increase again. He understood it is 45 to 100. Now he gives some 85, 87. And it is saying to reduce your guessing number. Means from 45 till 87. He got more clear. So he will give 70. It says reduce your guessing number. He understood it is 45 to 70. Then he gives 60. So it is saying to increase your guessing number. Means between 60 to 70, right? You got it? Superb. Now he gives 65. It says increase your guessing number. Now he's pretty clear that the value is between 66 to 70. Then he gives 67. It says increase your guessing number. So means you are more clear to close into your answer. So 69 he gives randomly. It says you guess it correctly. So this gives more kind of interactiveness. So this is one interesting way. But so here, did you observe one interesting point? I wrote if condition, elif I wrote. This is one more elif. In languages like Python, we have elif, not else if. This is one confusion for beginners, but you need to understand. And did you see that I didn't write an else condition? Yes, else is an optional. Else block is optional in Python. So when you write if condition, it's up to you. Even if else, if you want to write, you can write. When you have something like a elif ladder, so you need not write else. In this particular subject to logic, do you think else plays any role? Because if there are two values, either both can be equal, or one of them can be greater, or one of them can be lesser, right? There won't be a fourth condition. So for the third condition, you can write else, such that the same condition will be executed. Or there are situations where you can use else also. Hope you not understood. At the same time, there is one more problem that how many guesses user has done? 5 or 6 or 7 guesses, right? So what we can do? If the user guesses in less number of times, he will get more awards, means more score. else less score. If you want to do that, we can do that when you go for the while loop. So while and for loops. So after these conditions. Similarly, now to understand the usage of this else condition, in which case we can use else. To understand that, let me go and creating a small utility application. You are creating some utility tool which will give the office schedule. So means you are taking the office schedule, say from Monday to Tuesday, Friday, it should tell this one. Saturday, it should be telling this one. And Sunday, it should tell Sunday. And we need to take this value in runtime. So generally, we can take like, week of the day equal to Monday like that. But what if you want to take this value in runtime? So if you want to take a runtime, so we can go slowly. First, let's implement in an ordinary way, and then we can think of it. So first, let me take this example like this. Week of the day equal to Monday. Now, what are the condition? So initially, user can give Monday, Tuesday, Wednesday, Thursday, like that. So I will write a condition. It is like a elif conditions ladder. Did you understand? So not every time you'll have a single condition. Week of the day equal to Monday, or week of the day can be Tuesday. So it can be any of these 7 days, right? So for all these conditions, we know the value is same, but still we need to write the condition. Instead of separate ifs, I am writing elif. Means this all are related. If this is not true, only then the next one will execute. What if I write like if again? So a condition, both condition will not happen at one time. Did you see that if you do this if condition and again if separately, then both conditions will be executed. Rather, if I say elif, if the first condition is satisfied, it will not go to the next one. If the second is satisfied, it will not go to the next one. If nothing is satisfied, it will go to the last one. Generally, if you take the example of weeks, it will be from Monday till Saturday and Sunday, but not beyond it. So in this case, genuinely, we need else. Did you see? What if user gives some dummy thing? You don't want to process it, right? So I wrote it. At the same time, if you want to get this value in runtime, for that also we can write. So week of the day is equal to enter the week of the day I wrote. So fine. Now let's execute this one. Clear and Python C so and so. Week of the day is equal to, it is asking me, though I wrote like a Monday, I'm asking down again. I pass the same Monday. Means I will comment it. So week of the day I'm taking. So what is the schedule of Monday? 9 to 6. You got as desired. Now let me execute again. What if I give TUSD? Okay, Tuesday I give. You got 9 to 7. And what if I give, say, Saturday? Oh, I gave a spelling mistake, right? So did you see this condition was valid? So that's the reason in this case, it is needed. And what if I give like same thing Saturday? It's working perfect. So what if generally when I'm giving the same Saturday, unfortunately I gave one space extra. Did you observe? Unfortunately, I gave one extra space. Now then what happened? So Saturday is there. You gave the same exact case. You couldn't get the answer. So this is one of the things you need to remember. Whenever you are getting runtime inputs, you need to ensure to clean it. If you observe anytime, so the username passwords, any websites, when you're entering, sometimes you copy paste these usernames. Or like sometimes you write extra space also after your gmail.com or something. But still things works. How? Because they will do this kind of stripping. Strip. Now you understood, right? It's a string. If I want to remove the white spaces on either side, you can use strip. So in this way, it can clean it. If I do the same thing, now Saturday space, it works. If I do the same thing again, space, Saturday, space, multiple spaces I give, but still it working. Next, last important thing. What if I give Saturday? Did you see I gave the same thing, but still it's not working? The point is like you gave here title case. Did you see? It's not lower, it's not upper. But when you give the input as this lower case, both are not equal. Means if you remember in the Caesar cipher example, I told to convert everything to lower case. But here I'm trying to convert to title case. If you do to title case, now it works. So depending upon the situation, we need to opt for something or the other. It's working. Similarly, so what if you want to take all the things in a better way? So you want to handle. So instead of like this if method, I can go for a better method where you can see that. So the same things I'm assigning to multiple. If you observe, as the same condition is there from Monday to Friday, I wrote like a separate variable and I'm using in all the places. So this also works perfectly in the same way.